Question 10a. Show that f of x can be written as x plus 2 over x minus 3. So we've got to add the two algebraic fractions. Okay, so put the calculator down. Either you're going to do a cross multiplication and a common denominator, or you spot that your x squared minus 2x minus 3 factorizes, and that's going to give you an easier way of doing it. So I'll show you that way first. Okay, so it factorizes with 3's and 1's, and to make the middle terms right you need a minus there and a plus there, and you just double check that that's correct. You've got an x squared, you've got a minus 3x plus x, and you've got a minus 3. Lovely. So if you rewrite your first term as a quadratic factorized on the bottom, you might then hopefully notice that what you're adding on uses the same one of those two brackets. It uses the x plus 1. So we don't actually need to change the first fraction at all. All we need to do is times top and bottom of the second fraction by the x minus 3 bracket. Okay, so I'll just show you that step by step. If I keep them as separate fractions and just times top and bottom by x minus 3 like this, we've then got the same denominator. So it basically means we can now add the tops and we don't need to change the denominator at all. Okay, so you could, if you wanted to, just jump from that line to that line by incorporating this term with the x minus 3 times onto the top and then putting it over this denominator. If we multiply out the top like that, don't multiply out the bottom, keep that factorised. Factorised is always better. Let's just put that in a better order and join the 6x and the minus 3x together. And factorise the top, because hopefully it will factorise. Exam questions are normally designed to sort of do lots of nice simplifying and cancelling. Okay, so let's think about the signs. Yeah, they're all pluses. Okay, and then we can cancel, and we're there. We've got to the x plus 2 over x minus 3. Okay, so the other way of doing it is to just multiply the bottoms together and do a cross multiply. The problem with that is that you're probably going to get cubics, which then need more factorising. Okay, but it would work if you're careful and don't make mistakes. We're going to cross multiply, so times the top of that one by x plus 1 times the top of the other one by x squared minus 2x minus 3, and it's all over x squared minus 2x minus 3 times x plus 1. Okay, if we times this out, I'll times the brackets first, so that'll be a 3x squared, a plus 4x and a plus 1. I can times that out. Okay, and let's just keep the bottom as it is for a minute. There's not much point timesing the bottom out, you'll only have to refactorise it. Okay, so keep timesing. You can see you're getting this cubic on the top now. So you have an x cubed term. Your squared terms are there, so you've got a plus 4x squared. You've got a plus 5x and a plus 2. Now, obviously, we've now got a cubic to deal with. They're not really expecting you to do factor theorem because they're not really expecting you to end up with a cubic. They're hoping you're going to do the first method. So let's just use the calculator to sort out the cubic on the top. So pop in a 1, a 4, a 5 and a 2. So our first answer is x minus 2, which means our first bracket is x add 2. Our second answer is x minus 1, which means our next bracket is x plus 1. Now, we've got a problem because it hasn't given us any more brackets. There should be another bracket. If it's only given us 2 solutions from a cubic, it means one of these is repeated. And you can tell which one is repeated because of the n number you're trying to make there is a plus 2. If you repeated the x plus 2 bracket, you'd get a plus 4 as you timed it out. So it must be a repeat of x plus 1. Okay. So you can see that you've got to sort of think through all of that. It's probably easier to try and get your head around the first version I showed you. Okay, so we can cancel out one of them. We do in the end have to factorise our denominator and turn that into x minus 3, x plus 1. And then finally we get there. Okay, they won't take marks off you if you do this version, but you've got to do it right.